welcome to our very first podcast episode of a brand new series called The Waterloo Advantage. I am Dwani Patel, one of your hosts, third year software engineering student, and co-hosting with me is Mayank Kanoria, also a third year software engineering student. Today we have our very first special guest, Navya Mehta, who will be talking about his co-op experience at Loblaws. So welcome, Navya. Could you just introduce yourself to our listeners?
Oh, definitely. It's a pleasure to be here. So, hey guys, I'm Navya. I'm currently a third year student doing computer science and finance with a minor in statistics at Waterloo. Um, the last 2 years have been interesting to say the least, just trying to explore the data science and machine learning landscape. So it's been working at Genworth, where I worked as a data science intern working with like insurance products or recently with the Bank of Montreal Capital Markets, working on some of their trading algorithms. And most recently at Loblaws as an operations analytics and data science intern, trying to work on some of the product availability and operations questions that ultimately affect like store results.
Right.
So
Very cool. So what was your role at Loblaws recently? And like which team were you on there? Like what were maybe you can like give an example of a project that you worked on there?
Sure. So I won't get into a lot of specifics here, but I was actually on the operations analytics team, which essentially focuses on trying to find redundancies or inefficiencies across the supply chain that feeds a lot of your Loblaw stores. Is there maybe we have inefficiencies when it comes to certain types of products reaching stores, or maybe we are having some issues with accurately forecasting demand and therefore it leads to like lost sales. So a lot of those intricacies is what we explore. Can we build novel models that can take, say, certain products and the history of sales that we have for them and effectively recognize where we might be faltering in our processes and can actually improve and optimize. So it's a lot of machine learning, it's a lot of traditional optimization techniques, some unsupervised learning. It's an interesting landscape because it's not like traditional ML where you have like a label, a zero or a one that you're trying to learn. You're actually trying to discover patterns. And so it's a different set of problems that we're trying to solve.
Right. And so is like Loblaws pretty big on their like ML and data science team, or is this like something that they're recently looking into, or like do they have like a really big team at Loblaws for like data science specifically?
It's actually a really good team. So some of like a lot of the colleagues that I get to work with, they're like brilliant people across with backgrounds across statistics, business operations, um, chemistry, and so on and so forth. You often see a lot of that diversity when it comes to data science, mainly because it brings a different kind of perspective to the question. Because at the end of it, the kind of tools that you have to solve a lot of these questions are fairly standard. It's how you utilize these tools that really makes a difference. For example, how do you recognize which kind of significance test might be most appropriate for identifying, say, certain events? Or on the other hand, when you're trying to say build deep learning architectures, how do you recognize at a very high level whether the kind of data you're working with or when going into deployment, the kind of data sources you expect to be available would best suit what kind of design? So it's a lot of that higher order thinking, and that I'm really happy that I get to work with such talented people across the organization and actually get experience with how they work with these problems. So, yeah.
So, Navya, since this company is very consumer first, your products are being used by consumers, how important is understanding the core business operations of the company in your role as a scientist? And how does that maybe from something like a financial company like BMO?
So I think the way that I see it, there are two distinct sides to data science or like machine learning in general in industry. And I would characterize those two sides from my limited experience as business insights and like machine learning engineering of sorts. So what I mean by this distinction is that in some kind of roles, understanding the core business is a top priority. And this is specifically true for Loblaw, mainly because in a lot of scenarios, in some scenarios, yes, we are building deployable models, but in other scenarios, the final end goal is not a model. The final end goal might be as simple as a number, or it might be as simple as a set of observations like descriptive statistics that would guide us to make better business decisions. Maybe we find inefficiencies. We don't need models to correct them. We just need a recognition of that inefficiency that like humans can then proceed to correct in our processes. So in that sense, understanding the core business is extremely important, mainly because it's the core business that you're trying to optimize. Like you cannot exist in a bubble just building a model with no knowledge of how that's actually going to be used. So this actually differs from a lot of other situations where the purpose of like the data science role is fairly limited in the sense that it does not blend into the entire organization, but but is rather a distinct product. For example, again at BMO, when I'm building those trading models, I don't really need to have a very deep financial understanding of the products that we're trying to model, because that's fundamentally abstracted away from the model itself. And yeah, that is the fundamental distinction. So this was a new experience for me, mainly because when I was transitioning into my role here at Loblaw, I spent a significant amount of time actually understanding the different data sources, seeing how they relate to each other, what are like the data collection procedures. And it's been a refreshingly different perspective on data science as a whole.
Yeah, that's very interesting. And from the sounds of it, Loblaw sounds like a very interesting challenge to you, a very new challenge. And one thing that I'm wondering is, do you think Loblaw as a company is data science? As in, do they apply all these, analytics that you guys come up with to make decisions, or do you think they make decisions and then find statistics to back them up?
So, from my experience, I actually find it to be fairly data first. Again, I mean, this is from my own limited experience. I've been here for like a slightly less than 2 months as of now. But what I've seen is a rigorous appreciation for the metrics that we design and and like the insights that we discover, mainly because a lot of these products a lot of our analytics products have these time frames in which they move into deployment. And in that sense, they aren't just like sidelined as like for namesake, so to speak, because I mean, at least from our experiences, I've actually seen past analytics products made by our team actually in production.
And so, like, for the types of problems that you work on, would you say most of the problems that you deal on day to day are mostly technical problems, or do you also have to deal with like sort of adaptive challenges or people problems on a data science team? Like, is that one of the concerns, or not so much for the role that you are in currently?
So, I mean, I would go beyond the technical problems, but I won't call them people problems. I'll call them business problems. And what I mean by that is, yes, you have a whole set of challenges that you try to optimize. For example, what is the most efficient way to query a database so that like my spool space is minimized? Or how exactly do I calculate some metrics such that like my asymptotic runtime is minimized? Those are fundamentally technical questions that are extremely important when you deal with data at scale. However, apart from that, there are a lot of these business problems to deal with. For example, you may be like you querying particular fields from a database and trying to like use them to check their predictive power, but you actually need to understand where those metrics are actually coming from, who is actually calculating them. In a business sense, are they related to to like the final outcome that you're trying to predict? And in that sense, maybe you discover abnormalities like variations in some kind of data that you're finding difficult to explain. Can you link it back to the business processes that were generating it? And often if there were like human entry issues, or if there is like duplication, a lot of those data cleaning issues, how do we develop ways to correct them that are fundamentally linked to the way that the data was collected in the first place? So this again goes back to like the understanding of business processes, mainly because apart from like raw technical challenges, a lot of the problems that you try to solve are inherently linked to the operations of the business.
Right. And like, so would you say privacy is also one like an issue specifically with the data you work with, or is like data collection pretty easy for you guys? Because it's not too big, because you're not dealing with, too critical data, like maybe in a different application like healthcare.
So yes, I don't think that my team, at least I don't think I have dealt with any data that actually has those privacy considerations as such. So I don't think I can speak to that.
And
Right.
what do you say? So you mentioned that a lot of your issues are around things like data cleaning and processing. And would you say that that's something that's prevalent industry-wide throughout different data science teams across companies, or is that a very like Loblaws specific problem because of all the business logic that exists?
I actually think it's a important step in any kind of data science pipeline across any company in any industry. And this actually arises from two distinct methods, two distinct sources. So one of them is the fact that data science as a field is fairly new. Like the adoption of widespread machine learning techniques in industry probably took place over the last decade or so. And compared to that, a lot of these companies are far older than that. So when this entire wave for AI adoption and like smart business processes as such started, a lot of these companies had to migrate their data or actually make their old data, which wasn't collected with ML in mind, feasible for ML to be conducted. And so, in that sense, there are likely to run into data collection issues mainly because the original collection procedure was probably optimized for some other reason, or in a more likely situation, very stringent data collection procedures weren't enforced mainly because like it was a cost benefit analysis where at that point in time there weren't those significant benefits in the absence of widespread ML to accurate data collection. So, in any company, when you deal with large scale data, the first issue might be that, well, it isn't perfectly cleaned as you would expect. And so, a lot of that cleaning is mandatory. In at the second level, it's not data cleaning does not necessarily arise from dirty data as it does with data not suited for your needs. So even in an ideal world with perfect information with the most well-refined databases, you would still need to employ cleaning procedures mainly because every specific problem that you're trying to solve, say in an autonomous vehicle company, you're trying to build a model that can do motion detection and predict how different cars on the road within your lidar sensor are going to move in some amount of time. That is a very specific problem that might need the data to be represented or be present in your matrix or data set in a particular manner, while say some other problem which might be like accident detection or like those emergency procedures in an autonomous car that might need the data to be represented in a different way. So data
Right.
cleaning is that bridge between your central storage and adapting it to the method that you want to represent it as.
Mm-hmm.
Right. So just like quickly, if you had to give like a percentage for like how much you spend on like data cleaning, data parsing, data, augmentation versus data insights,
Yeah, just like
just
a
like,
breakdown of like what your steps
just
are.
just a break
Yeah.
exactly like what would you say, like, out of like your time, like you spend 60% on data cleaning, 40% on insights, or like what would you say based on like your experience so far you found this breakdown to be?
So, I mean, I don't think it does service to assign an exact number mainly because of how much it varies. But from my experience, I would say that at least a third of the time is spent on data cleaning itself, and
Right.
another third on data pre-processing. By pre-processing, I mean feature generations, developing algorithms to extract particular insights, and so on and so forth. and the final third might be like machine learning pipelines, deployment, and so on and so forth. But again, this
Right.
division differs based on like the data sets we have, because some data sets might be inherently cleaner than others, or some might need like lesser feature generation than others. And so while it varies significantly, from my experience, it's a fairly equal split.
Right. And then I know you mentioned that, like, like you said recently that, like, stuff like AI and ML is just very recently, very new for, like, making this deployment, making these pipelines. I'm wondering if, like, you've had to, like, I'm wondering how your experience has been with management and leadership at your companies, and if you faced any challenges around explaining to them, what AI really, what value AI really brings. What are the sorts of problems it can work on, or like, maybe like you might have had an experience where there's like a huge hype train, and so management's pushing for data science, but it might not be the right problem. Like, maybe speak to more about your dealing with management and leadership at your companies.
So I actually think that, at least from my experience, the adoption of AI or ML at the first place does not necessarily come from a hype train, but rather a recognition that it can add business value. And so justifying products or recognizing questions that the business needs to work on also comes from that important recognition of how much business value it is adding, say in monetary terms, say in terms of say discounted cash flows over time, or in terms of say metrics, probably like wastage or shrink or something that's reducing. There's always some method to recognize or to convert your data science projects to business metrics that are easier to quantify and, more importantly, directly linked to whether the business should invest in your project to begin with. And so, in that sense, it usually has not been an issue that I have experienced, which is like explaining the significance of a particular project to management. And often it is the case from my experience that when these machine learning teams are often built, the leadership for that technical team in particular is the kind of liaison that you have between your developers and management itself. So that kind of flow of information is well processed and segmented, and so communication usually isn't an issue, although it very well differs from organization to organization or project to project.
Right. So something very very interesting that I read in your bio, and I sort of want to get more into it, is sort of questions and your thoughts around data science. Like, from your bio, I read that, like, you seem like a guy that, like, very much loves data, right? And some of the very interesting points that I read were that you see data as a way to understand human behavior. You see data as a way, or data as a tool to find order in chaos. And the last one that I thought was very interesting was that you see you can see data as like a way to leverage data for the pursuit of meaning. Can you speak to, like, a bit more about your passion for data, and how, like, you can pick any of them or like all of them at once? Like, how can we leverage data for the pursuit of meaning, or to find order in chaos, or to understand human behavior? Like, could you maybe give your thoughts on that?
Definitely. So I'll just talk a bit about like the origin of that idea. It was that, in a sense, data science is not merely like, it comes down to how you view the field. Do you view it in terms of the technical aspects that models involve? Do you view it simply as a summation of, say, supervised and unsupervised approaches? Or do you view it in terms of the impact that it can have on society? Because when I got into data science, what really fascinated me was was that a lot of those problems that seem computationally expensive, or rather a simulation of chaotic systems, so to speak, are so well modeled by these algorithms. So I'll give you an example. There is a simulation. It's called the Game of Life. It's a single person automaton. It's essentially a game where you do nothing. You just start the simulation, and the environment affects the agent to move through different phases of time, so to speak. It's a fascinating simulation. You could check it out once. And the idea is that moving from one timestamp to the next is a very deterministic process. There are fixed rules that are being applied. But what's fascinating is that reversing from one timestamp to the previous one is not deterministic at all, because multiple of those states can lead to the same state. So in that sense, you put forward a very open-ended question: how do you reverse these simulations? That seems fascinating to me, mainly because what seems to be what is seeming chaos when it comes to, like, say, what that simulation is being perceived at different times through your entire duration. You're trying to find relationships or models that can accurately capture that. Well, how exactly do you do that? Do you view your simulation as, say, an image that you're trying to convolve over recurrently over your different timestamps? Or do you view it as an attempt to encode some underlying information, say a vector of sorts, from each of those frames, and then find similarities between frames to capture whether one would be the predecessor of the other? So the idea here is that when you try to model these chaotic systems, there are such interesting approaches, and each of them lead to such distinct outcomes. Is what makes the field so interesting. And when I talk about the pursuit of meaning, it's because there are so many questions that we can work on today that are intricately linked to rigorous data science. So, as an example, I believe right when the COVID-19 pandemic started raging through North America, there was actually an open data question that was posed to academia, which was that multiple medical records, including illness histories, were released in a attempt to find a particular algorithm that that can match causes with possible treatments. Or, for example, very recently there is an open question that's made by the City Business Collaboration for a Sustainable Future, which is the access to the data that you have are like corporate climate change disclosures and like city disclosures for a lot of their climate policies. And the idea is that based on these data sets, which are fairly unstructured, they may be reports, they may be blobs of text, they may be numerical data sets. How do you recognize what projects cities should prioritize in order to, say, effectively tackle climate change? Or what projects should they prioritize given shrinking budgets that are most likely to, say, add jobs and pull places out of recession? So in that sense, a data science is a very potent tool, mainly because its underlying premise, which is trying to find relationships, assess their significance and strength, is something that can be so easily and so uh, fundamentally applied at scale to pressing problems.
So, like, that's some really interesting topics you brought up, especially the game of life. That's something that I have read about myself. And something that I've been wondering myself is data science and machine learning are very powerful tools. But do you think of them as tools to help maybe programmers, or do you think of them as tools that would replace programmers or maybe other jobs?
I mean, artificial general intelligence is quite theoretical at this point, and I do not. I mean, I don't think I'm the most qualified by a distance to comment on this, but I, uh, there isn't exactly a way that you could posit that any advancements in artificial intelligence are fundamentally destructive to the notion of employment, so to speak. In the sense that, yes, there are jobs that can be fundamentally automated away. May it be, say, manufacturing roles where identifying defects and streamlining the assembly line might be something that, say, models might be more equipped to do. But at the same time, it opens up a host of new issues that need humans to resolve. So, in that sense, it comes down to businesses investing in upskilling their workforce because, yes, some current roles can be automated away, but that simply means that newer roles and newer responsibilities need to be
Mhm.
addressed. For example, models aren't perfect. You can go online and you'll find fascinating examples where of adversarial attacks, where, say, you have a model that's, say, trained to recognize animals. This is just a general example. You can change one pixel in that image to make, say, a zebra appear like a rhino. That's
Which is bizarre,
bewildering to
right?
think about, but that is the very idea of one pixel adversarial attacks, which is that you recognize what kind of relationships the model is placing on different patches of the image to be able to conduct your classification. And you can intelligently choose a single pixel that can throw off your calculations. So, when you think of a
Right.
human, do you think that changing a small subset of an image is so drastically going to change your output? Probably not. So, in that sense, adversarial attacks is a fascinating example of how human assistance is fundamental to deploying artificial intelligence at scale.
Right. And so, like, it's a good example of a question that, like, the data science sort of struggles with today, right? Like the adversarial attacks. But um, can you, like, what other questions do you think, like, data science struggles with today, but maybe could help in the future? Like, maybe today we don't have that many good models or that many good techniques, but you can, foresee that in the future, this data science will help us answer these
So
questions.
this is just some of my personal opinion, which is that a lot of the data science that we currently have is fundamentally limited by the hardware that we possess to train it. And what this essentially means is that two things here. Number one, a lot of your advanced models that already take a lot of time to train on a single batch. Say you build a multi-head convolutional network that passes several images through a convolution and then trains on their embedding, something that's fundamentally heavy. You take like a UNet, for example, or you take like a conditional generative adversarial network. Those are large models that fundamentally take a lot of time to train. And if you couple that with large databases, say, think about big data, think about businesses having records of multiple processes across the company. And when you combine the two, you just run into impossible training times. You add cross validation into that, where you train on subsets and try to evaluate your results on your validation data. And that compounds your training time even more. And that essentially means that either companies cannot adopt data science because, like, the time that will take to train and like run models on data is just not feasible for the business, for is not sensible for business processes. Think about, like, say, a real time like, think about an object detection model that takes hours to train or takes weeks to train. And therefore what that means is that you are either forced to work with limited data when training your models, or you're forced to work with simpler models when working with large data. For example, if you have data running into the billions of rows, it's not likely that you'd be using fancier recurrent neural networks or something. You'd probably go for like more for like classical machine learning approaches, including like tree based methods, or so to speak, in order to address, say, classification or regression problems. That essentially means that, as a fundamental consequence of the scale of your data set, you are limited in the approaches that you can use. And so that is kind of a hardware constraint because, I mean, I think I was just reading up about this for the last week. There was the idea of Moore's law, the idea that we can build processors that are an order of magnitude fast every couple of years, that essentially stops holding the moment you reach fundamental limits. And in that sense, do we see AI being limited by the hardware that we have to train and run inference on it. And so this is a fascinating field mainly because I've been reading about TensorFlow Lite and the idea of tiny ML, and the idea
Right.
that a lot of our current machine learning models might be exactly adapted for scale to be able to run on, say, low power, low memory devices. And that I see as the most fascinating trend, because that means that we're now trying to democratize like the deployment of models, so to speak, trying to put it at as many user endpoints as possible. And I think that that is one of the most powerful trends we have, because take like something like GPT-3, which is one of the most powerful linguistic models made till date, that needs several GPUs and TPUs to even run a single inference on.
Yeah, GTP3 is very impressive, but I heard they had to use like over like a country's like power just to train all that data, and like the amount of energy that
Exactly.
went into
So
it.
now if you need that kind of scale to train AI models, and because any kind of innovation, if you're trying to build a model better than GPT-3, that would essentially involve you'd likely need more complex model, like a more complex architecture to capture relationships. And so your training time, your inference time, it continues to increase, which keeps putting it out of scope of daily applications. So, how exactly do you make these revolutionary models accessible for immediate use? And that is where a lot of these ideas into like miniaturizing these models comes into play, and that is a really fascinating field.
So you brought up a pretty important point that a lot of machine learning applications are restricted by the scale of GPUs and power you need to actually train them. Do you think that fundamentally leads to a kind of monopolistic like sense in the field where some companies have the power and have the resources to create these models, and it's up to them whether or not they want to share these models? So for example, OpenAI is a for-profit organization, so they could very well create all these models with the huge funding they have, but what exists to restrict them from keeping it for themselves and having this monopolistic kind of stance in the industry?
I mean, I wouldn't necessarily comment on the monopolization of data, but I'd go to your first point about different businesses having a differing amount of ability to like host data science projects. And that is fundamentally true. And it arises from two distinct sources, one of which is being rapidly addressed, the latter not so much. So the first one is that you need significant infrastructure, which is your GPUs, your TPUs, in order to support training times. And that is a fundamentally high investment for companies to make, mainly because your returns are fairly delayed. If you start building, say, a data science project today, and depending on the scale of the project, larger projects that involve company-wide transformation are likely to take time, maybe 3 months, 6 months, a year, 2 years, which means that the business returns that you're expecting from that project are likely to be significantly delayed a few years down the line, while the investments that you're forced to make into not only hiring like your machine learning talent, but also setting up your setting up like your data processing, your GPUs, that needs to be made at the present. And so that delay often means that a lot of companies may not necessarily have the financial resources to make an investment of scale.
Mm-hmm.
And so what that means is if they actually do end up making that investment, there would be a focus on immediate returns from a lot of your analytics projects that may again introduce inefficiencies. So yes, the amount of resources that you need to set up a lot of your analytics teams, as well as maybe the delay that you have in like actually getting outcomes, is significant in affecting whether different businesses actually adapt or actually adopt these processes or not. And at the same time, it's not just about setting up like your GPUs or your those processing centers, because there is a lot more that goes into your entire machine learning pipeline that a company not doesn't necessarily have in place if it's just starting out in the space. For example, you may need to have a lot of your like data sets hosted on a database that's easily accessible to the scripts that run to train your machine learning models. You might need a system that to host your models such that they can be run in real time and integrated with business processes. Building a lot of this technical infrastructure also costs money and takes time. And so that adds to that delay factor that I'm talking about.
Mm-hmm. Yeah, and do you think the availability of data is a similar problem in the sense that are some companies restricted in the amount of data they can procure to train models, or is that something that's not too big of an issue in the field?
So that's again two sides of a coin, in the sense that in one sense there is so limited data is not exactly as much of a problem in certain applications as the excessive amount of data. For example, say you're dealing with like a video streaming company, like trying to build recommender systems for them, or say you're dealing with a social networking site where you're trying to find like the best friends to recommend, something on those lines. The amount of data that you probably have is humongous. You have information about, in the case of a recommender system, about every movie that was watched, the number of minutes that the movie was watched, whether pauses were taken in the middle, what kind of similar movies were seen, what other users have seen who also like that particular movie, how much a particular movie was rated. And that is a very high dimensional vector that you have for any particular user or any particular user movie combination. So now, when building any recommender system, it needs significant human intervention to recognize what kind of data might have the highest predictive power, whether there might be inherent dependencies that might render some data inadequate. And in that sense, there is that explosion of the amount of information you have, so that selecting the right data sources to build particular models becomes more important. On the other side,
Right.
the in some particular applications, limited data is also an important consideration. Consider, as an example, you trying to build a model to invest in a particular index, say on the TSX or the New York Stock Exchange or something. And there are particular stocks that had their IPO a few years back. And so if you have your daily price information, that's say around 252 trading days in a year, multiplied by say 3 or 4 years of data that you have. That's say 750 to 6,000 data points at the maximum that you have to be able to build predictions on. So in that sense, your data might be limited
Right.
because the space between two adjacent recordings is a whole day, and maybe that's not enough data points to be able to build, say, an autoregressive model that tries to predict like the direction of movement or something on those lines. So it is a combination of both, because there is so much data that you could possibly use. Take the stock example. You could possibly run like a semantic analysis on tweets to see what like public opinion is on that particular field. Or at the same time,
R
you
slash
might
Wall
run like
Street bets.
similarity with different stocks in that same sector and see how they are performing in order to like transfer the analysis here. And so it comes down to number one,
Right.
selecting what's relevant, and that is like the main question at the center of the solve.
Right. That's very insightful. And then I want to sort of like ask more questions on, because it seems like you've been doing data science for a couple of years now. You know, like you did it back in high school, you've done it in university for all of your co-ops now. I sort of want to pick your brain around the insights you've learned throughout this process. So I guess we can start with collaboration. Like, do you think collaboration has changed 2 years ago when you were working on data science compared to now, with having Jupyter notebooks that didn't exist before, or having more easy ways to share data, or like, can you comment a bit more on how you've seen the field change over your, like, the 2-3 years that you have been working in
So,
data
I mean,
science?
firstly, a disclaimer: the 2 3 years that I have is likely not does not encompass all the fascinating changes that this field has seen. But from what I can remember, I've seen when started, say, building my first model, I think pandas or even scikit-learn, a lot of these open source frameworks that support a lot of your development were several orders of magnitude releases behind, in the sense that I believe the current pandas version runs into like the 1.0s. The first version that I think I worked with was maybe a zero point 0.1 something. I don't remember. The point being that open source has developed so much over the last 2 years, trying to build better frameworks that actually meet the use cases that people in industry have. And so the actual a lot of the support that these open source frameworks have built is amazing, because it not only simplifies a lot of the development process, but it streamlines it, it makes it more efficient. And a lot of these new releases,
Right.
new libraries that have come forth mainly to meet very specific niches in the industry. So I take an example of PyCaret, which is a library that has a very fascinating feature, which is model comparisons. The idea that simultaneously can you view, say, a particular amount of process data and how it fits to a multitude of models across folds. And a lot of this functionality likely had to be built from scratch a lot of years ago, but now that like a lot of these libraries that are tried and tested by contributors, that are supported by the community, now have these features. It lets you abstract away your processes one step further, right? If you have a lot of that lower order machinery in place, you can try newer approaches, you can experiment easily, because the cost of experimentation is lower. For example, if you had to run like a model comparison experiment from scratch, would probably take you a day or two to actually build the infrastructure to compare models, and then you experiment, which means from the
Right.
point that you make a hypothesis to the point where you decide whether this step is relevant or not in your pipeline, it probably costs you a few days. The cost of experimentation is high.
Right.
However, the moment that you have a lot of these lower order machineries built into your libraries, your cost of experimentation reduces significantly, allowing you to spend more time in actually like trying and
Right.
testing different approaches and seeing how they work.
Right. So do you have like a hero or role model in data science that like, or like someone you really admire in your field that you sort of like want to meet or, aspire to become?
I definitely do. And I believe that there are a lot of figures across like machine learning research who have made tremendous contributions to the field. Everything from like building the first attention mechanism that was made for like natural language processing, to the advent of LSTMs, to like newer modifications that came with conditional GANs.
Right.
And however, the one person that I really idolize is Yann LeCun. He's a French computer scientist. He works with Facebook AI, and some of the models and some of the work that he's pioneered is fascinating across mobile robotics, computer vision, computational neuroscience, and more. And in that sense,
Right.
he's really a role model in the kind of impact that he's had on the field. I mean, very evidently shown by the Turing Award.
Right. Right. So I'm curious to like hear your point on like how data science affects like other areas of life. Like, do you think having this data science mindset impacts other parts of like life? Like, I know I've heard from other people that sometimes you start like optimizing your relationships, or you start seeing like variables in your relationships. Do you think that like data science impacts other parts of your life in a positive or negative way? Like, do you want
I
to
don't think
give me
I
thoughts on that?
have observed anything on those lines to make a reasonable comment here. But I mean, I just think that an important skill that it adds is the ability to be critical, in the sense that you might not accept statements at face value, but you are conditioned on this idea of significance. What is the likelihood of certain events happening? What is the significance, or what is the possibility of certain occurrences being conditioned on others? And that, in that sense, it offers you, I'd say, a more critical view of how processes work around you. But more than that, I don't think I have observed anything from personal experience.
Yeah,
Right.
that's
No, pretty
very
cool.
interesting. And something that I've wondered about is, especially not being somebody who's very involved with data science, what would you describe as like your ideal data science role? So let's say you had all the freedom in the world to choose and like pick and match whatever you want. Like, what would you want in an ideal role?
I'd say in my ideal role, I see a balance between the two ends that I had listed earlier. The two ends being, say, business insights and more scalable engineering. And so my ideal role would be focused heavily on machine learning research and trying to like adapt a lot of your academia research into like industry viable projects that can be actually that can actually be used by businesses at scale, and actually building that scalable inference infrastructure that can be used to like run these models real time. And so again, here you see it's a fine balance between, say, a lot of your software engineering problems when it comes to numeric computation and dealing with problems that come with like building infrastructure at scale and fundamentally ML research questions to begin with.
Mhm. Yeah, and so something that I know, like knowing you personally, is you try to think of solutions to problems like in everyday life. So if you're doing a CS course and you think of an open problem, you'll try to come up with solutions. And one thing I'm wondering is, how do you think your data science training impacts those questions and those solutions that you come up with? And do you think data science is very intricately linked to the core CS fundamentals that you're learning at school?
So two things here. I think data science is linked to core CS fundamentals mainly because a lot of the technical problems that you try to address are a link to a lot of the theoretical computing aspects that you study in school. Everything from, say, asymptotic analysis, from building efficient building efficient data structures that serve specific needs, or say just creatively building algorithms using existing ones that meet particular requirements of the problem, so to speak. And to address your second question, yes, I think that uh, I really think that the fact that I've been fortunate enough to work with data science roles through my co-op experiences, it actually shapes the way that I would look at a particular problem. So I remember one of the problems that you'd mentioned on a recent conversation we had, which was how do you measure the efficiency or like the success of a particular NBA player based on what position in the draft he was picked? Like, just this is a fairly open problem. What metric do you define your success on? What is the time frame you're defining success over? And just trying to think about these problems
Right.
methodologically breaking them into like these smaller subsets. I find that process fascinating, mainly because it I think it allows you to see a lot of these open-ended problems in something that's more manageable, something that can be actually answered empirically. And in that sense, yes, it is fascinating
Right.
because based on the kinds of projects that an individual enjoys within like the broader domain of like machine learning, it's likely going to shape the way that you approach open problems to begin with.
Yeah.
Right. Out of curious, like philosophical questions, like do you think human life and society can be modeled as an optimization problem?
I mean, when you talk about it very theoretically, sure, there are optimizations to be made, but at the same level, there are a lot of these generalizations that you make when talking about optimization problems, mainly because whether it's constrained or not constrained, what variables are actually trainable or not, whether there are some fundamental restrictions, maybe like equality bounds that need to be maintained. And in that sense, modeling the world as an optimization problem is harder, mainly because there are a lot of these hidden constraints that might dictate how our behavior should be, and also because there is sufficient stochasticity in the way that a human mind behaves, so to speak. So at a very
Right.
philosophical level, sure,
Right.
it's an optimization problem, but I'm not exactly sure to what extent of an optimization problem it is, that it is solvable, or that attempts can be made to like mathematically approach it.
Mhm. Right. And so, like, what kind of worldview would you say you find more appealing? Like, do you think the world is more deterministic or stochastic?
I would say that it is fairly stochastic. A very fundamental example is the butterfly effect. It's the it's the basis of chaos theory, because yes, there are underlying patterns to how different things may behave, but at a very high level, there is sufficient stochasticity that it may compound over time or over phenomena, such that your predictive accuracy is fairly low. So at that fundamental level, sure, there is sufficient stochasticity in the way that things operate around us, that it is difficult to predict the state of every variable at any point in time. Because when we try to make models to predict, to simulate our worldview, we make simplifying assumptions. Everything from, say, take the example of a Markov chain, where you assume that every state is only conditioned on the previous one. Does that really hold in the world? Will what happens tomorrow only be conditioned on how things are today, or is there like some kind of memory that's maintained over time? So in that sense, that is what I meant
Right.
by there being hidden variables and relationships that we cannot model, because there are a lot of processes that we do not know exist, or we know exists and we do not know how to model.
Right. So I just have one more, just like on the same note. Do you think the world, do you think we're living in a simulation?
Define a simulation here. That see, that's the thing, right? Like the
So
moment
like,
you begin to abstract away into philosophy, you reach philosophical nothingness, if that makes sense, because you're trying to reason about the existence of a simulation, so to speak. But fundamentally, a simulation can be, it is an occurrence that derives meaning from external sources. Something is a simulation only if it differs from a reference point outside its existence, which can be seen as reality. If you're talking about the world being a simulation, what is your reference point of reality? So at that end, the idea of simulation itself may not be defined.
right, no, fascinating. You just flipped the question.
And so something that you mentioned while describing your ideal data science role is that you want to work on bringing academic solutions into the real world, if I understood that right.
Yeah.
Is that the kind of impact you want to create? Like, is there some definition of impact that you have in mind that you really want to achieve?
I'd say there isn't any particular definition of impact, so to speak. The way that I envision an ideal role is that it adds sufficient value to the end. So there are two stages to it. It adds sufficient value to business processes, and the business processes add enough value to my theoretical version of ideality, so to speak. In that sense, an ideal role would be something where I believe my work makes a positive impact towards, say, a certain metric or towards certain goals that I think I should strive towards. And so yes, it's about trying to bring like I wish to work at that intersection where you're trying to bring a lot of these academic solutions to industry, mainly to address problems that I think are fundamentally satisfying to address, problems that are truly elemental to the way we operate as a society. So I mentioned a few examples before. How can we leverage analytics to build sustainable cities? How can we leverage it to build better policies for climate change? Or how do you leverage it to say improve last mile deliveries and like improve connectedness? Those are very fundamental problems that address like core human needs and core behavior, and those are the kinds of open-ended questions that I really would enjoy working on.
Yeah, that's a really interesting way to approach that idea. I understand that even defining impact at such an early stage in our career is very difficult. So, like, your idea sounds really interesting, and it's something that I think everyone should strive to do, like creating positive impact and trying to define what positive means to you. Now, I think we're coming to a close. So before we end, would you have any like bits of advice for incoming students or people trying to get into data science, or even in general, like life advice that you've just gotten
I
through your
don't
20
think
years?
I'm anywhere qualified to be giving life advice right now, but the one thing that I think has really helped me over the last few years is just, yes, it's cliched. It's just the idea of being curious in the sense that every time that you see a new research problem, yes, you try to address it with like the machinery in your toolbox that you currently have. But there is always a recognition that that machinery is never enough. The fact that there are always new approaches out there. Consider something fairly straightforward, like consider like the game of life reversal that I was mentioning. Yes, you could treat it as like image, like computer vision problems. Maybe you can treat it as like a image generation problem, probably as like a recurrent network where you view different frames. But at some level, there are always newer methods to visualize your problem set, and so always being open minded, always like whenever you come across a new method, maybe say spending a few days researching it, understanding how it works, like say trying to apply it to newer problems. That I think that iterative process is really helpful.
Right. Well, Navya, thank you so much. It's been such a great pleasure to learn more about your co-op, your passion for data science, and your insight in this domain. I think this has been an amazing first episode with such a humble and intelligent person. So that's it, folks. See you next time with another episode on the Waterloo Advantage.